My name is Igor Miniailo. I'm a lead architect of Magento, an Adobe company, and today we will talk about how to actually decouple Monolith on microservices. So the biggest spoiler for today's presentation that even so that the complexity of the work decoupling the monolith on the microservices actually is really big, and the changes to the code base will be introduced really big as well. So it's going to be pretty drastic changes to all the infrastructure we have right now. We are not going to deprecate API which you are currently relying on. So all the APIs which currently exist and which used for integration, for extension, for customization, supposed to be forward compatible as long as possible, and we will be really careful regarding introducing any backward incompatible changes. So we care about you, we think about your needs, and we are trying to accommodate all your desires in our design. So we are not saying currently about the alternative way which fully substitute existing monolithical deployment. We are just saying that we have started the shift towards the microservices. So don't consider, I said probably this is the biggest shout out here, that all the APIs which currently exist should be preserved in future. So, or at least most of them. So don't consider that we will start, along with starting the decoupling monolith, we will start to introduce backward incompatible changes, and we will start to making the breaking changes to Magento. So, but before, because all the such projects, especially such a big project and initiatives, should be responding to some business desires and to some business requirements. So that we started, so let's consider what particular problems the initiative of making decoupling the monolith on microservices actually replies. So what are the main Magento issues and difficulties you are currently struggling with? So I have on the next slide a list of the issues which we consider you are struggling with, but just to make sure that we are on the same page, just tell what particular issue you consider the main in Magento right now. Any issues in Magento? Complexity. So the complexity. Is there anything else? Front end. XML, actually, it's not a problem. It's one of the benefits, it's an advantage of Magento. Because with XML comes the extensibility of Magento. Is there anything else? So, performance, yeah, performance. Scalability. So, this is good. Good enough. Because I already started to think from the beginning that Magento is almost perfect. So, yeah. One of the biggest problems, and actually one of the problems which mostly both merchant and system integrators usually complaining about, is the backward incompatibility while upgrading even for patch releases of Magento. Another thing is complexity. So the application is constantly growing, and actually this makes you impacted as well. So because your customization is also getting more and more complex. And this leads from the Magento side for big bang releases. Because even making some changes to particular component in Magento, we need to retest, we need to recompose, we need to redeploy all different possibilities of how Magento could be deployed, and we need to apply all the possible business scenarios. We need to proceed with the manual regression, with automatical regression, and just to make sure that this particular change, even introduced to once or a few components, would not affect the whole product. And actually, this is a problem because merchants can't effectively react on changes on the market, so they can't effectively make quick decision. So this is actually supposed to be supposed to be answered by the goals of the current project, which is the service isolation. So we want to introduce, in the scope of this project, we want to solve next goals. We want to provide the component replaceability and provide to easily substitute Magento components with some external components, with some external system, and maybe even with SaaS services. We want to provide an ability of the granular upgradability of all the particular components, not affecting all other components which were not involved into the scope of change beyond introduced. Also, we want to address the scalability and performance, and to provide an ability to scale particular components independently out of others. Because it may usually happen that we have just one particular bottleneck in our system, and this particular bottleneck should be addressed, but not the whole system. And of course, we want to provide for merchants the agile platform. So the merchant may start small and start to expand lately on the same platform, not making the replatforming and the big redesign of all the infrastructure and the code base. But now let's get back to the current state. Let's get back to the monolith. So if you've been to Ricardo's presentation yesterday or Yis's presentation today, you may heard about the different styles of the writing code for application. So it was in 90s, it was stated that there were spaghetti-based code where we have so many different coupling and dependency. And then we go to the N-tier architecture. So usually it was 3-tier architecture. So the layered architecture, so which was depicted as a lasagna style coding. And then we go in the nowadays we go into the ravioli style coding. But I'm from Magento, and you know, guys, Magento was always famous for the localization. And taking into account that we are in Poland, let's call it not ravioli, but pierogi-based architecture. And actually, it would be more precise comparison because, you know, like ravioli are very small. They are as small as microservices. But probably, as you may know, nothing is micro in Magento. Because in Magento, actually, the components are the pierogi size, not the ravioli size. Because in our case, our isolated services, and actually this is the reason why we don't call them microservices, actually will cover particular business domain. So for each and any particular domain, we will introduce own isolated service. So getting back to the existing monolithical architecture while having different layers, we still have quite a lot of coupling between these layers and quite a lot of incorrect dependencies among the layers and among the different modules and components in the same layer. And this is actually one of the drawbacks of the monolithical architecture because the boundaries of the components are highly vulnerable for incorrect dependency to be introduced by developers who work on particular project. And as you know, on Magento we have a lot of developers working, and a lot of the developers making contribution, including the community contribution. So it's really hard to prevent the incorrect dependency beyond introduced. And actually, this is one of the vulnerability of the monolithical architecture. And the high coupling of component introduced the problem for scalability. And actually, this is one of the limitations we have in the system, actually for all the monolithical system. So all the monolithical system are scalable by multiplying just a whole application and deploying on different services and just putting some reverse proxy or reverse proxy or router just in front, just to route the traffic among all these application services. But we can't particularly scale the bottleneck. And if you know that our bottleneck, for example, checkout, we can't just scale checkout service independently out of all other services. So the big coupling we have right now actually prevents us from doing this. And this is one of the main ideas, and probably this is the main slide of the whole presentation, which is supposed to provide the actually basic idea. So in the scope of my presentation, I wouldn't be talking about API too much. So if you want to hear about APIs and the particular architectural approach, how it would be implemented and what the design requirements we introduce them, I really recommend you to stay and listen today's presentation of Anton Kryl, so the director of architecture of Magento. So he will tell more about that a little bit later. But here, I want to describe actually the strategy how we will be migrating from Monolith to the service-isolated architecture. And here you may see that we already not have a monolith here, but instead we have two independent applications, so the storefront application and the store management application. And you may consider it right now that everything which shopper or customer interact with on Magento, this is the storefront application. While all the set of functionality, which you probably used to call admin panel or backend, so the part of the functionality which admin or merchant interacts with, so it could be considered as store management part. Usually, you used to differentiate this functionality by areas in Magento. But along with this, both code which related either to those or those functionality usually located in the same modulus. And this introduced the problem of independently deployment admin panel, for example, out of the storefront. And for a long time, we internally in Magento considered that, for example, the catalog management part shares the same domain and shares the same business responsibility as the storefront part. But then we started, like, we gathered requirements from merchants, we gathered requirements from system integrators, and especially the critical point for us was the Adobe acquisition, because you probably you start to feel that Magento started to target upper market, and we are getting more and more bigger merchants, which requirements are slightly different, or maybe not slightly, but different in comparison to the mid-market. And especially high-end merchants, so big enterprise merchants, have really strong requirements for scalability. And usually, this merchant consider Magento as a storefront, as a flexible storefront, which they want to integrate with already existing e-commerce solution like SAP, like Oracle, like Microsoft Dynamics, like other ERP systems they already have in place. So that they just consider Magento as this system, but they don't consider, and actually they no need functionality of this system at all. So they already have a system in place which provide, for example, product information management, or order management, or inventory management, or marketing management, and so on and so forth. So they actually no need the functionality at all. But taking into account that currently we have a monolith and currently we have all this functionality coupled all together, it's just not possible to decouple this part of the system and easily replace it with some external integration. And this is the main initiative of the service-isolated integration. Architecture is to decouple these two applications. So currently our main desire here is to introduce so we already have this application, and we consider that the store management is the existing monolith. While we started to implement the storefront application as a greenfield development, and we started to implement it layer by layer, and I will briefly describe you how exactly we started to develop this application. So actually, this is the idea of replaceability. So we have pretty the same system, and you have the storefront which is deployed, and it's totally not affected when merchant, for example, decided to substitute our internal inventory management and the order management with external system. For example, in our case, this is Magento Order Management, which is SaaS solution, and which is fully substitute, and moreover, it's provide own functionality on top of our out-of-the-box order management and inventory management. And this is SaaS solution, and you can see here that this is just two components being replaced, while the whole storefront application is not affected at all. Actually, the storefront application is pretty much agnostic to what's happening underneath. And yeah, so this is regarding the split in this architecture. And you may see here that even the same components which are currently, or the counterpart components which are currently described for both storefront and store management, they are depicted with the same colors just to easily see these counterparts, but they have own domains, they have own namings, and actually they have own set of APIs. And so, for example, you may see that for catalog on storefront, we have a counterpart which is a PIM system, which stands for Product Information Management. For checkout, we have a CPQ. For customer, we have CRM. For order, we have order management. So these are typical system, especially enterprise merchant you usually have. And this system supposed to be easily replaceable with like out-of-the-box implementation, really simplistic implementation which we provide out of the box, supposed to be really easily replaceable with this external system. And yeah, and just to validate this idea, because if you still have some concern whether the catalog should be split on two different systems, like a catalog and the product information management, you may consider that even such values and the metrics like the read-write ratio is really different. Because, for example, for the storefront, the catalog read-write ratio are going to be like 98 to 2, like I mean 98% for read and 2% for write. While for the product information management, for all the operation happening in Magento admin panel, there is much higher ratio for the write queries. So that, what it actually means? It means that the API for the storefront and store management for the same operation like a product save should be different. And what it means, another thing, that their stack of components and even the database storage, it should be different as well. Because, for example, taking into account that on a storefront we have much more read information, our database storage should be more efficient for reading data, while for admin panel it should be more efficient for writing data. So actually this demonstrates the segregation between two different bounded contexts in terms of domain-driven design. And of course, the availability of the platform is guaranteed by the isolation services and stable APIs. So that, what it actually means, that this is like desirable state of the platform when we will have, you can see here that we will have two different entry points. The one entry point for our store management application and another entry point for the storefront application, which will proceed through, because we going to keep supporting the REST API endpoints for admin panel, and we consider currently that for store management application, the REST APIs are more reasonable than GraphQL, while for storefront application, we will be supporting GraphQL endpoints. And here you may see that how we are trying and how we are going to eliminate all this excessive coupling we currently have right now. And Yis already mentioned during his presentation on PWA that we started to proceed layer by layer. So initially, because I already mentioned that the storefront application started being developed as a greenfield development. So that means that we started to introduce a client, which is a PWA, and this client introduced the requirements for the underneath layer, which is GraphQL. So the GraphQL is a communication language for the PWA and how the PWA storefront approaches the server side. So it approaches via the GraphQL, and building the API for the GraphQL we introduce the requirement for the underneath layer. Because initial GraphQL implementation, which you may see, for example, in Magento 2.3.1, 2.3.2, and 2.3.3, in the implementation of GraphQL resolvers currently rely on the same service contract we already have in Magento. For example, for product repository, or all the other services you usually may find under the API namespace. But this is probably not the best choice, especially for the GraphQL. Why? Because one of the main advantages of the GraphQL is to provide possibility to not, because our existing service contracts are really REST dependent, because they extract entity as a whole and they persist entity as a whole. And but for GraphQL, it's not typical, because actually one of the best advantages of GraphQL is that it provides the possibility to request just a limited set of fields, which really needed for particular storefront scenario, and persist this particular number of fields. We now need to extract the whole entity, and we need to persist the whole entity, because we just want to make we just want to save just all the data which were affected by particular scenarios. So that but our existing implementation of GraphQL resolvers rely on our API, which don't support that. So when we build this GraphQL layer and we stabilize it, so as Yith already mentioned, it's more or less ready. We're still introducing some changes, but actually we have pretty much stable coverage. We started to introduce the storefront API. So this storefront API are supposed to address the problem which are not addressed currently with our service layer in Magento. So they're supposed to be really lightweight API, which provide the possibility to make, let's say, apply patch changes to the entity, but not save entity as a whole and not retrieve entity as a whole. And then it's quite interesting that we have the two different possibilities here. Because what I started my presentation with, that I started it from the spoiler, saying that we will preserve the monolithical deployment, and actually this is implementation, so this is kind of conditional logic, which wouldn't be, of course, implemented as a conditional logic based on if. It would be a little bit more sophisticated, but of course this complexity would be responsibility of Magento, but not you guys. So it would be done. This is the branch for the monolithical implementation. So unless we have the monolithical deployment where the whole application request is still handled by the one operation system process, it would be handled in the scope of this process, and we will just will go to the implementation of the storefront API, which will proceed with the new database access layer, which is additional layer, which is currently beyond developed as well, because currently we want to introduce another layer of abstraction. We don't call it ORM because it's not really ORM, because it's not really entity related. It is more field related. So currently we call it database access layer, but maybe we'll introduce some tricky fancy name for it. And another stuff, if we have the microservice deployment, so here is the point of the decision making. I will take a little bit more about this point on the next slide. So we may decide to make a decision to make a routing to the service which is deployed somewhere on another physical environment, maybe another server, maybe on another data center, maybe in cloud, and we will just route this request to that server. So that what it actually means? It means that your logic, I will show it on another slide. It would be so. Actually, this is the storefront API. So we have the proposal which you may scan. Actually, I don't know in the 21st century anybody makes scanning of the QR code. I know, so I just put it. But actually, I never did it for myself. But we have this proposal where we already describe how the storefront API should look like for the catalog. And you may see that it is much more simplistic than, for example, our interfaces for catalog repository, for example, for product repository or for category repository, because our services may operate with just an arrays, but not array of objects, and we no need to recreate a numerous number of objects to work with the services. So they're really lightweight services. And here you may see how the inbound data may look like, and how the payload look like, and how the output of the service may look like. Still, you may find it scanning this barcode, and actually you see it's really simplistic. And the main idea here is just to provide the possibility to specify it. So the API should be, we call it greedy. So they should provide you possibility to retrieve just all the data you particularly requested. And we now need to return more data than it's currently returned. So for example, like just a quick example, we may introduce just a particular attributes, like here we want to return items with a name and price, and we don't want to return other data regarding the product. And we also don't want to return any other aggregations except the category aggregation. So all the requested data are being returned here. So the API must be fast. So this is currently our internal measurements of the storefront API. So I did not mention that. Let's get back here. So the storefront API implementation, so as I already said, that we released the GraphQL, let's say, we introduced an API, and usually when Magento introduces API, we start to proceed with the forward compatibility for this API and start to support it as long as possible. So this limitation work for the GraphQL schema we introduced. But along with that, we started to make changes to the GraphQL resolvers. Because as I already mentioned, existing implementation of GraphQL resolvers will mostly rely on existing service isolation and service contracts in Magento. So currently, we started to re-implement it based on the storefront API. So here you may see the difference in performance between current implementation and the implementation which may be released pretty much soon. So you can see that this is really significant, because this new implementation currently relies on the new API more aligned with the GraphQL paradigm. Here you may see another graphic which just describes how the steady growth of the existing implementation after the 17th percentile, which just shows that we have some bottlenecks probably on the database level here. And here we have the gradual growth for all other scenarios on our existing implementation, which actually just demonstrate that we started to apply the more proper way of the working with the GraphQL endpoints. So another thing that, as I already mentioned, that the biggest challenge for us, and actually not just for us, but for all service-isolated or microservice architecture, is not actually to build this and to make this decoupling, but organize the communication between the components, because the network is a really scary place to be. And usually when we make the development of some particular business logic, we don't usually think that we usually rely on so we usually make some wrong assumption, like that latency is 0, the bandwidth is really wide, and that network topology is the same, so network is not changing. And we make so many false assumptions, so that when the application is beyond deployed on particular infrastructure, we start getting to particular problems, and it's really hard to resolve them. So this is the place where the service mesh comes for. And actually, this is the layer which is supposed to provide the possibility of the communication between services in a network. So what we want actually to introduce here, we want to introduce here the way, so the infrastructural layer for business service communication. And this infrastructural layer is supposed to be provided by Magento. So we don't want to overcomplicate your extension or your customization. So your extension and customization supposed to follow all the business rules, and they should not contain any infrastructural logic at all. All the infrastructural logic, like how to route particular service, whether this service call from the catalog, from the checkout to catalog, should be done in the scope of one process, or it should be routed to independent service. How to find it, how to discover that particular service, how to check whether this service is still responsible or not, because network is a scary place to be, and at some point of time, the service which was replying successfully just started to fail. And actually, all the distributed system, no matter how they were architectured and deployed, may lead to the problem that even some localized problems happening on some really localized infrastructure or server may lead to the wide catastrophic problem to the whole application. So this is responsibility of the service mesh, which is supposed to resolve all this network problem. So you may consider a service mesh, so another analogy here, so you may consider the service mesh as a TCP/IP protocol, but for application layer. So the main responsibility of TCP protocol is actually to deliver message from point to point, no matter how. But actually, it's pretty much the same for service mesh. So service mesh does not care whether the particular payload data is encoded or not, in what way they formatted. So the main responsibility is to deliver from one service to another, but along with it, and actually this goes beyond the analogy with the TCP/IP, so the service mesh introduced a possibility to explicitly track the application flow in a lifetime, because the TCP/IP implementation for the application layer is mostly implicit and not evident at all, while the service mesh makes this really complicated communication explicit, beyond trackable, and monitored by the application layer. So this is actually the main idea of the service mesh. Probably, I forgot another thing, and I just need to mention it here, because you may see here the storefront BFF and the admin BFF as well. And the BFF actually not stand for best friend forever, unfortunately. But this is another layer which is supposed to provide routing for request for external requests, like PWA, so the client which make a request. It's supposed to provide this routing among the internal services deployed, because all this routing should be implicit for client, because client should know nothing whether it deal with the monolithical deployment or service isolated deployment. For client, it should be the same straightforward as it was before. So client may rely on just one entry point, and it may consider that application is always monolithical. And this is the responsibility of this layer of the backend for frontend. So it's supposed to provide the routing from external requests to internal services. So you may consider it as a north to south flow, while the service mesh is a distribution of requests from among these services, so east to west flow. So two additional layers which are supposed to provide efficient routing for external request and internal request. And now we might see how this new application will work. That we have the product information management, we have the storefront catalog, data from this system in some way, let's say, magical way, will go on a unidirectional flow to this data, to this system, and probably in this case it would be, so as I mentioned, it would be read-efficient database. So in this case, we're supposed to use for catalog Elasticsearch, while for product information management on admin panel, we're going to use MySQL as we do it right now. And this is how the system may look like. And you may also pay attention here that all our version of the system, like Magento open source, Magento commerce, Magento B2B, introduce own modules which should be deployed for this particular isolated service. And this is how, for example, we may substitute checkout with SaaS checkout implementation. And especially here, it's important that taking into account that the number of permutation, how the system may be deployed and delivered, like how the system may be deployed is just innumerous. We may consider that MFTF coverage is not an optional anymore, because any other automated test can't provide you the same coverage as MFTF, because only MFTF now provide the possibility to cover with the same test both checkout, which is local, along with the checkout, which is locate a request to the cloud. Because even our current integrational tests are really coupled to Monolith. With our existing integration test, because our existing integrational test, actually they mimic application, so that they're coupling an integration test even more than our applicational logic. So what it means that with the existing integration test, we may not cover this scenario here. But we can do it with MFTF test. And the great idea that even if you already have this functionality, if you already have functionality in place, you may cover it with the MFTF test, and then your functionality would be both protected for different deployment patterns, like this and the previous slide. And of course, we want to introduce some administrative tools to make possible to make auto-scaling of particular isolated services. Like here you may see that the customer isolated service is deployed with 3 different instances with a load balancer which point and route the request to all the particular containers. And all of the above will provide us an ability to get rid from big bang releases. So these are releases which we do right now. So we're getting more and more functionality. We start to process this functionality. We go through manual regression and the automated regression, and we release it. While with the service isolation, we will go with independent releases of components, and it should drastically decrease the risk of possible backward incompatible changes, and it should reduce time for like supplementary cost for a release process. And that was pretty much all. Yeah, so I almost fit in my time slot. Thank you.